Now we can move on to the second order differential equation. Okay, yeah, a second order differential equation. Suppose a second order differential equation is something like this. Okay, what is a linear second order differential equation? Yes, a differential equation is linear, which in a sense, like, for example, y double dash plus a function of y dash p of x y dash plus into q of x y is equal to r of x, right? Here if you see that the power of the degree of all the differential equation terms are like 1 is 1 only. See here, okay, the degree is 1, the degree is 1, everywhere the degree is 1. Okay, the degree is 2 means then we can say that this equation is like not a linear equation, it's a non-linear equation. For example, if I'm saying that y double dash the whole square plus py y dash plus is equal to r of x means this is a non-linear equation, because here the power of y double dash is 2. Otherwise, let me take this equation, p of x into y dash is equal to r of x, something like that. See here also the degree is 2, right? Because it is a product of y and y dash. Y is the dependent variable. Okay, if the dependent variable has some product terms or something, means definitely y into y dash the power will be 2. So this is also a non-linear equation. Okay, so our major focus will be only on linear equation. We are not considering any non-linear equations. Okay, the solution of non-linear equation will be very difficult to solve. That's not your part of the syllabus, but usually they'll be giving you one equation, and they'll be asking you whether it's a, you have to say the equation whether it's linear or non-linear. So try to differentiate the equations. What is a linear equation and what is a non-linear equation? Okay, now we know this is a linear equation. Okay, linear equation, because the power of all the different variables are 1. Okay, in the RHS, if it is 0 means then it is homogeneous first order linear, second order linear equation. Okay, if the r of x is non-zero means then it is a non-zero non-homogeneous linear ordinary differential equation. Okay, if r of x is 0 means homogeneous linear ordinary differential equation. If r of x is not equal to 0 means non-homogeneous linear ordinary differential equation. Now let us move on to the first method. In the first method, what I'm here, instead of p of x and q of x, I'm saying p of x and q of x is a function of x. Okay, guys, instead of that function of x, if it is a constant coefficients, okay, majorly your syllabus is only this guy. Okay, constant coefficients. Okay, y double dash plus a of y dash plus b of y is equal to 0. If you're having a form something like this means, okay, this is your second order differential equation. Okay, if your form is something like this means, let me assume like a solution like y is equal to e power lambda x. If we assume a solution as e power lambda x means, find y double dash y and y dash and y double dash and resubstitute in the equation. Okay, since e power lambda x, right, y dash is what? Lambda e power lambda x. Y double dash is lambda square e power lambda x. We resubstitute in the equation and take the common factor out. We can see that this is our like characteristic equation as equivalent to the differential equation. You got it, right? So y double dash plus a y dash plus by is equal to lambda square plus a lambda plus b. So I don't want to go to the derivation and all, because that is not the scope of this course. Okay, if you want means I will upload the notes in the internet. You can see the derivations. Okay, these are the derivations, okay, I don't want to go there. Directly we'll go to the result part. The result is, if that from the roots, okay, from the characteristic equation. So this is our characteristic equation, right? This is our characteristic equation, lambda square. Okay, so my characteristic equation is lambda square plus a lambda plus b is equal to 0 means, okay, get the solution of this equation. The solution will be like, since it is a second order second order polynomial equation, we'll be getting two solutions. So lambda 1 and lambda 2. Okay, if you solve this solution, the roots will be 2 roots will come, right? So the answer, one second, yeah, just note down the formula, that's all. If the roots, both the roots are real and distinct means the answer is c1 e power lambda x plus c2 e power lambda 2x, that's all. Okay, then if the roots are real and equal means then c1 plus c2x into e power lambda x. Okay, instead of lambda I'm using variable m, so nothing else. So m square plus am plus b is equal to 0. Okay, so I'm solving this equation. Finally, I'm getting two roots, m1 and m2, means this is my solutions. Then for complex roots, my answer will be like, for m, I'm having a complex roots alpha plus or minus beta, means okay, beta I. If I have something like this, means the solution will be nothing but e power alpha x into c1 cos beta x plus c2 sin beta x. That's all, nothing else. This is the solutions, the three different solutions. Okay, I hope this concept is clear.